कैसे हो आप लोग। तो आपका स्वागत है मेरे एक और नए वीडियो में। तो आज मैं आपको दिखाने वाला हूँ, आज मैंने सर्च किया वाइट ड्वार्फ ब्लास्ट पिक्चर। तो देखिए कुछ वाइट ड्वार्फ का ब्लास्ट का पिक्चर है सर। ये यहाँ पे बहुत ही अच्छे से एक्सप्लेन किया गया है, जिस पे हम लोग जाएंगे particle supernova blasts white dwarf star across the Milky Way. The material ejected by the supernova will intensely expand very rapidly, but gradually slow down, forming an intact giant ball of hot glowing gas. Eventually, the charred remains of the white dwarf that explode will overtake the gaseous layer and speed out onto its journey across the galaxy. Images crediting Mark Gralick, University of Warwick. A strange white dwarf star halting through the Milky Way may be the survivor of a particle supernova. New study finds white dwarfs are cool, dim Earth-sized cores of dead stars that are left behind after average-sized stars have exhausted their fuel and shed their outer layers. Our sun will be one day become a white dwarf, as will more than 90% of stars in Milky Way. Previous research found that white dwarfs usually have internal structures arranged in layers. Their cores are mostly carbon and oxygen, which is usually surrounded by a layer of helium and then a layer of hydrogen. Astronomers meaning white dwarfs usually see just hydrogen, just helium, or sometimes a mix of helium and carbon. Although there are expectations that hint an unusual pasts. In a new study, scientists zeroed in on the white dwarf SDSS J1240+6710, located about 1,430 light years from Earth. Discovered in 2015, prior work found this white dwarf had an unusual atmosphere that seemed to possess neither oxygen or hydrogen or helium, but instead was composed of a weird mix of oxygen, neon, magnesium, and silicon. Researchers in this new study used the Hubble Space Telescope to take a closer look at the white dwarf, and they identified carbon, sodium, and aluminum in the object's atmosphere. This makes this white dwarf apart from any other previously known. They said. In this study, the scientists also found that the white dwarf was traveling about 5,60,000 miles per hour, 9 lakh kilometers per hour, in the opposite direction of the way in the galaxy is rotating. Moreover, it had an especially low mass for a white dwarf, only about 40% the mass of our sun. When we found this unusual white dwarf was really low in mass and really moving fast. That really triggered my curiosity into what happened to it in its past. Study lead author Boris Gansike, an astrophysicist at the University of Warwick in England, told Space.com what might explain all these stranger details about the white dwarf. The researchers in this study think that thermonuclear explosion didn't completely destroy the white dwarf, but rather a partial supernova blasted what remained of the object across the Milky Way. Supernovas are the most powerful star explosions in the universe, bright enough to memorably outside entire galaxy. They can occur when a white dwarf dies from siphoning off too much mass from a companion star. All the extra weight from the stolen mass squeeze the white dwarf's core, which drives the core's temperature and density high enough to set off a thermonuclear chain reaction that explosively obliterates the white dwarf. In the case of SDSS J1240+6710, the scientists noted the elements seen in the white dwarf's atmosphere could have all been produced in the first thermonuclear reaction of a supernova. However, there is a clear absence of what is known as the iron group of elements: iron, nickel, chromium, and magnesium, and manganese. These heavier elements are normally cooked up from lighter elements, and their absence in this white dwarf suggests it only went up part of the way through a supernova, failing to reach the high temperature and then needed to forge iron group elements. That's what makes this white dwarf unique. It did undergo nuclear burning but stopped before it got to iron gansic said. When it had its supernova event, it was likely just brief, maybe a couple of hours. The research suggested that SDSS J1240+6710 was small compared to white dwarfs that normally undergo thermonuclear supernovas. As such, only a miniature supernova may have occurred. A type lacks a partial supernova weak enough to leave behind most of a white dwarf. In the old days, research would have thought that a thermonuclear supernova would destroy a white dwarf entirely, but in the past 10 or 15 years, scientists have found it is possible that a partial supernova could not that leaves part of the white dwarf behind burned and charred. Gansick said the explosion is not powerful enough to totally disrupt the star. The explosion would have blasted SDSS J1240+6710 away from its companion, ripping matter of the small white dwarf and hurling it through deep space at the speed at which it orbits its partner. Gansick said the scenery will help to explain the white dwarf's speedy puny size and bizarre atmosphere. Based on SDSS J1240+6710's mass and temperature, the scientists estimated this particle supernova occurred about 40 million years ago. Much remains unknown about the white dwarf's companion, and researchers think it could have been white dwarf much like SDSS J14140+6710. Previous research into the origins of thermonuclear supernovas is largely focused on larger white dwarfs. Now that this new study suggests that smaller white dwarfs can undergo similar explosions. Future models call not explore how their outer bursts and their subcute remains might look gansik said on larger white dwarfs. Now that this new study suggested that smaller white dwarfs can undergo similar explosions, future models call explore gansik said, thanks to the Gaia space mission, which was able to identify more than 50,000 white dwarf candidates, we can examine that white dwarfs to get a much better idea of what happened during that type of particle supernovas. What are the products of burning gansik said? Hopefully, we'll be able to identify a few dozen similar systems. We can start to go from one weird outlier to a small class of system. Future results could also explore whether astronomers may have already detected the brief dim flashes of light, Gansik said, and his colleagues suspects are of lights. Gansik and his collegious suspects are linked with this kind of strange white dwarf. It will be interesting to see if they will be able to find a very short supernova, like even that likely were just dismissed until now because didn't look like supernova. Gansik said since they were too so short, the chances were very slim to catch one, and there was very little time to follow up on whether any such detection was real. But it principle the data suggesting the events are real exist somewhere. The scientists detailed their finding online just July 15 in Journal Monthly Notice for the Royal Astronomical Society. Follow Chelsea. गाइस तो आज के लिए बस इतने, मिलता है अगले वीडियो में, तब तक के लिए बाय बाय। एंड आज का वीडियो कुछ ज़्यादा ही हो गया क्योंकि आज हमने जाना पार्टिकल सुपरनोवा ब्लास्ट वाइट ड्वार्फ स्टार अक्रॉस द मिल्की वे, एंड इस स्टार का नाम था SDS J1240+6710। तो आज के लिए बस इतना, मिलते हैं अगली वीडियो में, तब तक के लिए बाय बाय।